All right, so on page 7, question number 41, um, it says factoring trinomials, but they want you to factor out the GCF first and then factor. So notice that you have 12n squared plus 50n. Okay, this is on page 7, plus 50. Now, what you should notice is that there is a GCF among these three numbers. Okay, so what is it? That's the question. So what is the greatest number that can be divided by all of these numbers? Okay, so we said 2. So this is what you would do. You would divide all your numbers by 2. So that means the 2 is factored on the outside. And when you divide each term by 2, you end up with 6n squared plus 25n plus 25. Right? If you don't do that and you start off by using the X method and you just simply start factoring, your answer is not going to be completely factored. You will get some factors, but they will not be in simplest form because they're going to end up having a GCF that you should have pulled out. So be very careful. You always, and really this should always be your first rule of thumb, is to look for a greatest common factor first. Okay, so even if you were doing problems 35 through 40, your first rule of thumb should be, is there a greatest common factor I can take out? Because if you don't take that out and you just simply start doing the A and the C term and going through that process, your answer is not going to be completely factored. Okay, so now we're ready to factor so we can get our binomials. So what I'm going to ask you to do is to go ahead, since now you know how to use the X method, multiply the 6 times the 25, get your number at the top, get your numbers at the bottom, and then we'll come back and see what your answer is in a second. So I'll give you a chance to work on it. All right, so let's take a look. This is what you should have. So you should have the 150 at the top, 25 at the bottom. 10 and 15 will give you 25. And then you divide it by your A term, which is 6. Okay, so we reduce 10 6, 5/3, reduce 15 over 6 to 5 over 2, and then you just start from the bottom up. And again, guys, it doesn't matter which one of these factors you write first. Okay, now you do have to make sure in your final answer that you have this 2 on the outside. So if you don't, your answer would not be correct. Okay, so all of that is the answer, including you have to show that there was a GCF taken out at the very beginning. Okay, all right, let's do one more of these, and then we're going to get into some special cases for factoring on the next page. All right, so question number, let's do question 43. So we have 12p squared plus 46p plus 30. Okay, so now we're going to multiply 12 times 30. Okay, what's 12 times 30? So if we take out a 2, because we actually need to do that first, we have 6p squared plus what? 23p plus 15. Okay, so now let's multiply 6 times 15. And again, sometimes a hint is these numbers are very big. So that's a hint that I need to make sure I'm looking for my GCF. So can someone tell me what 6 times 15 will be? All right, so we got 90 here, we got 23 here. If someone would check their calculator to give us the factors. All right, 5 and 18. We divide that by 6. We cannot reduce 5 6. We can reduce 18 over 6, and we want to reduce that to 3 over 1. Okay, so now we can put in our factors as 6x plus 5 and x plus 3. And again, it doesn't matter which factor you write first. All right, so let's move on to page 8. On page 8, you'll see what we call special cases. And I can tell you the most common mistake in problem number 45, students think they can just simply square 3x and square the negative 2. That is not what that's asking you to do. Okay? So when we, just keep in mind, when we square a number, we are writing down the factors 2 times. So you're doing the exact same thing if it's a binomial. You're writing this down 2 times. You're not just squaring the first term and squaring the second term. Okay? So it actually ends up being a trinomial when you FOIL this out, or when you distribute it out. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Same thing for the middle. Negative 6x. Negative 2 times negative 2 is a positive 4. So your final answer is 9x squared minus 12x plus 4. So that's the most common mistake that students think, I see that squared, I'm just going to square both numbers and be done. So please don't make that mistake. And I'm going to show you a pattern with the second one, and then I'm going to show you a shortcut that you can do this. But a lot of students unfortunately, will make the mistake with the shortcut. So that's why I always show this way first. Okay, because sometimes when you take a shortcut, okay, you also then run into the problem of making a mistake. Okay, if you FOIL it out the long way, you'll always have the right answer. Okay, but for those of you who like shortcuts and you think you can do it, I'll show it to you in a second. Okay, so I'm going to do 47 the long way, and then I'm going to show you a shortcut way. All right, so we're going to write out 4r plus 5 2 times. I'm just going to write it beside it. Okay, then I'm going to distribute it like I did the first problem. So I'll have 16r squared plus 20r plus 20r again plus 25. So that's going to give me 16r squared plus 40r plus 25. All right, so what happens is you can see that the middle terms are always the same. Like this is minus 6x minus 6x. This is plus 20r plus 20r. It's going to repeat itself. So if you can remember that, you could say, okay, I'm going to square the first term. So this is a shortcut way. But again, guys, don't use it if you don't think you can get it right. So this is what you would do. You would say 3x squared is 9x squared. 2 squared is plus 4. Now, how do I get the middle term? You multiply these two together and then double it. Okay, what's 3 times 2? 6. Double that, you get what? So there's your 12x. Okay, now that's the shortcut way. But you got to be able to use it correctly. Okay, if not, FOIL it out like I did problems 45 and 46 and do it the long way. All right, so let's do 48 the shortcut way. Square the first term, you get 9b squared. Square the second term, negative 5 times negative 5 is a positive 25. Okay, multiply the terms inside and double it. So what is 3b times a negative 5? Okay, double that, you get a negative 30b. Okay, so again, if you feel like you can't do that, then you need to FOIL it out like we did in the first two problems. Shortcut way, there's a shortcut to actually factor what we call a perfect square trinomial. Now, how do I know that this is a perfect square trinomial? Is the same rule that I just applied with the shortcut way. Okay, so this is a perfect square. 4 is perfect. 9 is perfect. Is that true? What's the square root of 4? 2. So it's almost like this is how you test to see if it's a perfect square trinomial. that means that you would not have to use the X method and factor it out. Can you use the X method, factor out, get the same answer? Absolutely. Okay, but again, this is just a special case, so I'm showing you a shortcut way to do it. So you would take the square root of 4, which we know is 2. You take the square root of 9, which we know is 3. Okay, so I'm testing it now to see if it is an actual perfect square trinomial. I multiply the 2 and the 3 together. What does that give me? Double it, you do get 12. That's how you test to see if it's one of those perfect square trinomials. You take the square root of the first term, the square root of the last term, multiply those answers together, double it, it should equal the middle. Okay, that's how you know you have one of these special cases. So if that's the case, here are your factors. That's it. You're done. Now, can you get it using the other method? Absolutely. Okay? So if you can't recognize that or you can't test it to see, then you would just default back to what you learned before. You can also write it this way. That's an optional way of writing it. Okay? Now, I'm already telling you that 49 through 52 are perfect, so I already know it, but I want you to be able to test it if you had it on a test to make sure that you know that it is a perfect square trinomial. So here's our test. What's the square root of 25? What's the square root of 16? 4. 5 times 4 is 20. Double that, do you get the middle term? Yes. So that's how you test to see if it's a special case. If that's the case and you have all plus signs, then everything will be a plus sign, and now you have just factored that out. Okay. All right, so let's take a look at this one. Okay, the square root of 36 is what? 6. The square root of 1 is 1. What's 6 times 1? 6. Double that, you do get your 12, right? So what do you think the factors will be here since this is a negative 12? 6x minus 1 squared. Because the middle number is negative. Okay? If the middle number is negative, then that means your binomials will have a minus sign in it. Okay? What's the square root of 49? 7. Square root of 25. So we double that, we get 35 times 2 will give us 70, so it tests out. But there's a minus sign, so my factors are just 7x minus 5 to the second power. Okay, or you can write it as 7x minus 5 times 7x minus 5. Okay, but again, if that's confusing, you can default back to your X method. Okay, just gives you a shortcut for special cases. All right, let's look at another special case. Okay, first I want you to look at these 53 through 56 and tell me, what do you notice about all of these? What do you notice? Something's special about them. Yes. Very good. So what you notice or should notice is that they're the same binomials, except one's a plus and one's a minus. Same numbers though, but one's a plus, one's a minus. 3x minus 7, 3x plus 7. 3x minus 8, 3x plus 8. 6 plus a, 6 minus a. So when that happens, and I'm going to first do it the long way, but again, then I'm going to show you a shortcut. When this happens, then you're not going to have a middle term. The middle term will cancel out. Okay, so let's work it out first the long way. So I'm going to actually start with 54. 2p times 2p is 4p squared. And we learned how to do this in a couple days ago. 2p times 7 is a positive 7p. So now when I distribute the negative 7, 14, my fault. Thank you. So when I distribute the negative 7, they're going to cancel out. So this is going to give me a negative 14p. And then negative 7 times a positive 7 is negative 49. So these middle terms cancel out. I'm left with 4p squared minus 49. So we call this difference of two squares. Okay, most of the times we just say differences of squares. So in that case, you're never going to have a middle term. Now, can you FOIL it out the long way and just see that they cancel out? Absolutely. But if you notice they're just opposites, all you would have to do is multiply the first terms and multiply the last terms. That's all you would have to do. Multiply the first terms, multiply the last terms. You're not going to have a middle term, so they're going to cancel out because they're opposite, so you would not necessarily have to FOIL it completely out. But guess what? You can. All right, so these are just special cases. Now, go down to the last part. This will be the last part of this lesson. So notice this is just the answers to what we just got up here. Correct? So how do you factor it and get it back to here? Okay, so if this is a squared minus 1, okay, so you know 1 is a perfect square. This is like 1a squared. So what's the square root of 1? 1. Okay, so it's a perfect square. Square root of 1 again is 1. So all you write is a plus 1, a minus 1. There's no middle term. Okay, that is a minus sign there. So these are just very quick ways to factor if you can identify special cases. So now what gives this one away is it's a binomial. Notice there are only two terms. They are binomials. And not just that, the numbers in both binomials or both terms are perfect squares. Okay, so they have to both be perfect squares, both numbers, and it has to be a binomial. It has to be a minus sign in order for this to work. If this had said a squared plus 1, you would simply write the word prime. Prime means you cannot factor it. So that minus sign is very important. It has to be a minus sign. Both terms have to be perfect squares. So let's look at this one. 4 is perfect, 1 is perfect, and there's a minus sign. So I can factor it 2n plus 1 and 2n minus 1. Okay? 1 is perfect, 9 is perfect. 1n minus 3, you just take the square root, and 1n plus 3. 25 is perfect, and 9 is perfect. So you just take the square root of both numbers. 5k plus 3, 5k minus 3. There is no other way to factor these except for what I just showed you. You cannot even use the X method here because you don't have a B term. So you have to be able to recognize a binomial, perfect squares, minus sign, take the square roots, and write them as opposite sides. That's it. Okay. All right, so that is the lesson. So you'll be able to do the next assignment on the